What is up, Astro Geeks? It is your boy Aphelion back with another episode on the Ephemeris podcast, and I'm coming to the tail end of a roller coaster weekend. Let's put it that way. Competed at a Science Olympiad Invitational on Saturday. And I kind of thought it was gonna go better than it actually ended up being, but yeah, it was only because my hopes were high and, things didn't turn out the way I wish they would. But that's okay cuz we competed against some pretty tough schools across California, so I should still be proud of myself is what I'm trying to say. But that is definitely not the topic of discussion today, just a little tangent I thought I would start the podcast off with. Today what we're going to talk about is probably it's a pretty hot topic in the astronomy world because it's really in your face. So black dwarfs is what we're talking about today, and at face value it's intuitive to believe that there is an end to a star, like it completely fades into darkness and it goes from a white dwarf to a black dwarf. But it really isn't that easy. There's a lot of stuff that goes behind the idea of a black dwarf existing, and there are many reasons why it's still a theoretical stellar remnant over being an actual thing. So we're gonna get into the meat and potatoes of that conversation today. So let's start off with the definition. So as I mentioned, black dwarfs are very much theoretical. The time requirement for them to actually happen, if they do exist, it exceeds the age of the universe. Like, even if these black dwarfs were to form just when the Big Bang happened, which is very, very, very improbable, it still would be a white dwarf at about, a couple thousand Kelvin, in terms of temperature, because we all know stars have temperatures. And they're very difficult. They will be very difficult to detect, because obviously once a white dwarf cools to about the temperature of cosmic microwave background, it'll be taking in a lot of electromagnetic radiation, which makes it difficult to detect, similar to dark matter, which is also another hot topic in astronomy. So there's also just a quick side note. They are believed to be the remnants of brown dwarfs, and when brown dwarfs were discovered, astronomers first believed that they were black dwarfs. But obviously, we've differentiated the two at this point in time. So, talking about white dwarfs, brown dwarfs, all these kind of dwarfs might be a little bit confusing if you're new to the podcast. So I'm just going to break it down really quick. White dwarfs are remnants of stars. When the star reaches the end of the main sequence, it usually becomes a red giant, and it sheds all layers outside of an inert helium core. And when the red giant the red giant before becoming a white dwarf will become a planetary nebula, where there's just the inert helium core in the middle, and there's a bunch of interstellar medium around it, as it's shedding as the red giant is shedding all its layers. And so what you are left with in terms of the core of it is obviously the white dwarf, and it's supported by a bunch of electron degenerate matter. And once this white dwarf has fused all the elements that it can, and it's radiated all its heat, it just pretty much fades into this shadow realm of the universe. And our ideation of a white dwarf becoming a black dwarf is that its mass would still exist. So that would be the only clue we would have if a white dwarf does become a black dwarf. So why is it still theoretical? Like, it seems pretty intuitive at this point. Surely we should take it as a given. But as I've discussed before, it takes an eternity. Let me give you basically, if you look up articles on a black dwarf, it'll give you estimates of about 10 to the power of 15 years for an event like this to occur. So it is a long, long, long time, as quoted from some articles that I've seen, hundreds of millions of billions of years. Yep, you heard that correctly. And more importantly, there are like still holes in our understanding of the universe that kind of contribute to the theoretical aspect of a black hole. It's like, first of all, we've got dark matter. We don't even know how to detect that, so it would be difficult for us to detect a black dwarf in itself. And there's a little thing called weakly interacting. What is it? Its abbreviation is WIMP. I believe it stands for weakly interacting. I can't remember what the MP stands for, but basically the existence of these particles. They're particles. The P stands for particles. I just forget what the M is. They may elongate the life of white dwarfs, so making it even longer than 10 to the power of 15 years, which is already huge. And then there are things like proton decay that may occur within white dwarfs. And just to put it into simple words, it's another one of those quantum things that exceeds the age of the universe. And it may also prevent like a black dwarf from actually existing, because if a white dwarf is unstable and proton decay is occurring, it's difficult for black dwarfs to actually reach a temperature where we would assume that it radiates absolutely nothing. So yeah, these are, as I mentioned, these are really instrumental to understanding if they actually exist, how they're possible. And I don't know, it really feels like like this one philosophical debate that I can remember. Like, if a tree falls in the forest, does it make a sound? Like, the obvious answer there would be yes, based on like what we've witnessed and what we've understood. But there's always that other side of the coin that's just like, well, there's perhaps a chance that our perception of the universe is slightly conceited, and maybe there's something we just have not kind of comprehended about this whole situation. And I mean, it's already a bit of a wild story in itself, considering how many holes in the understanding there is and the whole theory behind it. But if I were to mention the additions to this black dwarf theory story, it would amaze you, and I'm going to amaze you with the amount of information that I'm about to blast at you about the possibilities of what black dwarfs can be after they're black dwarfs. And this comes in the form of the hypothesis that black dwarfs turn into supernova, which, think about it for a second, is crazy. But look into the details and it gets even crazier. If a black dwarf exists, there may be specific kinds of nuclear fusion involving quantum particle interactions, which I'm genuinely not going to delve into. It's like, if you look into Wikipedia articles that explain all these kind of fusions that happen, it gets really complicated. So just to put it into simple words, if a black dwarf exists, there may be specific kinds of nuclear fusion involving complex quantum particle interactions, and they will alter the stability and the mass of the black dwarfs. They'll kind of mess with it. It'll make it possible for a black dwarf to be stable, but it will make it much smaller. And making it smaller will exceed what we call the Chandrasekhar limit, which is pretty much the mass that a white dwarf has to have to be stable, right? And because it gets smaller than that limit, it will lead into boom, explosion happens, like everybody wants to see in stellar evolution. But the big thing is, if white dwarfs becoming black dwarfs takes 10 to the 15 power years, getting to this point of black dwarfs exploding into supernova from getting so small would take multiple universes. Like, the biggest of these black dwarfs would take 10 to the power of 1100 years to happen. And for the smallest, 10 to the power of 32,000 years. That is a huge number, thinking about it. I read that number and my eyes nearly popped out of my socket. That is a large number. Just imagine writing about 32,000 zeros on paper. I'll give you a rough estimate. Maybe that'll take you like a day. 32,000 zeros to write that takes a day. Think about how much time that actually is. That's crazy. It blew my mind. Like I went scouring for some of the biggest numbers we know, like grains of sand on Earth, and these are baby numbers compared to 10 to the power of 32,000. Yeah, I'm running out of breath getting all excited about this. It's really just a number. I mean, if you try to type it into your calculator, you'll get to like 10 to the power of 320 and it'll give you undefined. So yeah, at that point, you're referring to infinity. You're referring to infinity. But yeah, as crazy as this story has gotten, obviously there has to be the big catch with the hypotheticals that, get this crazy. Um, so there's an issue to black dwarfs becoming supernova because if proton decay does exist, it wouldn't give enough time for a supernova to actually occur. Like the fusion would just happen too quick, and there wouldn't be enough time to go big boom. Which is unfortunate because I'd love to believe, I'd love to believe in something like that. But yeah, that's just that's kind of the end of the road for all of the cool things about black dwarfs in terms of how it relates to us, relevance and significance, which I think is important to talk about a lot. Is that in terms of the sun becoming a black dwarf, which has been talked about a couple of times on some articles, we assume it's possible given that black dwarfs do exist and there will exist a universe full of black dwarfs. And I believe I read an article where a theoretical physicist who wrote about this topic said when the sun does become a black dwarf, it's pretty much just going to be when the universe is just pretty much done with all forms of star formation and galaxy formation. There will only be remnants left in the universe, and that's kind of when these black dwarfs are going to exist. But there are theories out there that might suggest that there's no time for that to even happen. Like the big crunch and all that kind of crazy stuff, which we'll probably get into in some other cosmic theory episodes that are definitely coming up. I'm trying to get to that. But yeah, in terms of relevance and significance, sorry, I was off on a tangent. It's a long time until the sun becomes a black dwarf because we know it's going through its stellar evolution. It's going through swimmingly. So I mean, I guess if there's one fun little thing to take away from this episode, it's that you can sleep easy tonight knowing that the sun will rise tomorrow, right? If you didn't take anything else away from the crazy story of black dwarfs. But yeah, that is all I've got for this episode. I hope you enjoyed. I think this has been one of the most fun podcast episodes to research because of finding a number like 10 to the power of 32,000. I don't know, maybe that gets me a little bit too excited. I should probably, keep away from the numbers. But yeah, if you liked what you heard, make sure to follow the podcast on Spotify. In terms, I was plugging my podcast to some of my followers on Instagram, and they said they had accessibility issues due to Spotify being locked on other regions. So I'm trying to get it out there to more platforms. Hopefully that will get done in the next upcoming week or two. And until next time, it has been your host, Aphelion, and I will catch you guys later. Peace.